All right, let's look at the homework 14.7, problem number 2. All right, so let's look at part 1. All right, so we want to find the partial derivative with respect to x. All right, so let's find that. So the partial derivative with respect to x would be, all right, so partial derivative of x cubed is 3x squared. All right. And a negative 12xy, so it's going to be negative 12y. And partial of 8y cubed with respect to x is 0. So that's that. So how about the partial derivative with respect to y? All right. So partial of x cubed with respect to y is 0, since it's considered to be a constant. All right, so partial of that would be negative 12x. All right, then partial of 8y cubed would be 3 times 8, 24y squared. All right, so we got that. All right, so we set partial with respect to x equal to 0. We get x squared equals 4y, so we have to divide through by 3. We get that. And here, we're going to get, let's see, if you divide this guy through by 12, so you're going to get the negative x plus 2y squared. So it's going to be 2y squared here. All right, so let's submit. All right, it came back and looks like we got part 1 correctly. All right, so let's look at the part 2. All right, substituting x equals 2y squared into x squared equals 4y. So we're going to have 4y to the 4th. So we put this guy in here, so square that. 4y to the 4th power minus 4y. So put that on the other side of the equality. All right, then we obtain y equals, you can factor out 4y. You get 4y times y cubed minus 1. So y equals 0. And also y equals 1, because you're going to have y cubed minus 1. So it's going to be 1. All right, let's check the answer. All right, it came back and looks like we got the part 2 correctly as well. All right, so let's look at the part 3. All right, so when y equals 0, all right, so y equals 0, x is equal to, all right, so when we have y equals 0, we can have, let's see, x is 2y squared, so it's going to be, x is going to be 0 as well. And if y is 1, then you have a 1 squared, so it's going to be 2. All right, so let's check the answer. All right, it came back and looks like we got part 3 correctly. All right, then we have to find a second partial. All right, so first partial is given here, so we take the derivative. So we're going to get 6x for that, and the mixed partial will be if you take the partial of this with respect to y, so you're going to get negative 12. And the partial of y, so we have another partial with respect to y, so that's 0, so we're going to have 48y. All right, and then if you plug in 0, all right, so you plug in 0, so that's going to be 0, and times negative 12, so that's going to be 0. And actually, sorry, I messed it up. All right, so this is going to be 0 times 0 minus negative 12 squared. So it's going to be 144. All right, and at the 2, 1, so if you plug in x equals 2 and y equals 1, and this one we have to do a computation. Let's see, if you plug in 2 here, you have 12. All right, multiplied by, and y is 1, so it's a 48. All right, minus 144. All right, so I'm going to cheat a little bit here. All right, I'm going to go ahead and compute this using GeoGebra. So it's a 12 times 48 minus 144. Alright, so it came out to be 432. Alright, so I'm going to just put the 432. Alright, so d of 0, 0 is negative. We can conclude that it's a saddle point. Alright, so let's submit. Alright, actually I messed up here. It's actually minus negative 12 squared, so it's going to be negative. Alright, so submit again. Alright, it came back and looks like we got part 4 correctly. Alright, so let's look at the part 5. Alright, since d of 2, 1 is positive, and we must also examine, so second partial with respect to x, 2 at the 2, 1. Alright, so remember that the second partial is 6x. So if you plug in x equals 2, so that's going to be 12. Right, so 12 is a positive number, so we know that it's going to be a bowl facing upward, right? So we know that the 2, 1 is going to be a local minimum, right? So let's submit. All right, it came back and looks like we got part 5 correctly. All right, so we want to find the local max and the local minimum and the saddle points. All right, so saddle point is, let's see, the 0, 0. So I'm going to put here, it's going to be 0, 0, All right, so if you put the x equals 0, y equals 0, function is going to be obviously 0. So it's going to be 0, 0, 0. All right, and the local minimum value looks like local minimum happens at the 2, 1. So if you plug in, 2 for x, right, and 1 for y, so it's going to be 2 cubed is 8 minus 12 times 2 times 1 is minus 24. So 8 minus 24 would be minus 16, and then plus 8. So it's going to be minus 8. So minimum value would be negative 8. All right, so hopefully I did the mental computation correctly. All right, and local maximum value, which we did not find. So I guess this is going to be does not exist. All right, so let's check the answer. Submit. All right, it came back and looks like we got everything correctly. All right, that's it. I hope that this was clear.